let's find the correlation heat map. For this we need the library Seaborn, and I already imported it here, so I don't need to import it again. But for your understanding, I'll just write it here that you need to import Seaborn as soon as. Okay. Now Seaborn, it makes beautiful heat maps. We can calculate the correlation metric, and you need to remember that we are going to do it on our original data set, okay, before we apply the model. So if you remember, let me just zoom the window for you a little bit so you can see things clearly. Let's go back and let me just show you. Okay, here this is this is our original data set. Okay, so I'm gonna work on it, but I need to do it not in numpy but in DataFrame. So I need to convert it into DataFrame because the DataFrame structure is good and fine. One thing more is that 1 means strong correlation, strong positive correlation. 0 means that there is no relationship, and -1 means that it's negative, so it's in opposite direction. So to draw the heat map, first and foremost, what we need to do is that we need to define a variable. So let me just define a variable do numeric. Okay, and here I'm going to use pd. Okay, and dot DataFrame, and I'm gonna call my dataset x. Okay, it depends which name you have gone to your dataset. Now the next thing is that I need to calculate the coefficient, the correlation metric on pair numbers. Okay, one thing more that you need to remember, that if your data set has text such as names, then you can't get the correlation metric, so you need to convert it into numbers as we did before. Now all we need to do is define a variable correlation metric, and you also need to make sure that you have not used the variable before, okay, because it will create confusion for you. And then all we need to do is define the numeric, okay, call our variable, and here we just have to use correlation, and that's it. But here don't forget your r. Okay, now the next thing we need to do is we need to draw the heat map. And to do that, we need to do is field dot figure, and I need to choose the fixed size, and let's say that it's at 6. Okay, you can also improve it if you want to. And what else we need to do is that we need to use SNS, the Seaborn, okay, and heat map, and here we just have to call the correlation metric. You can see it here. Okay, and I need to add these. I need to add it to true, and you also need to add CMap. Okay, so let's cool it down, cool warm, and I also need to choose the decimal. So empty, it's gonna be, let's say, 2 decimal. Now let's just add the title, plt.title, and so feature correlation heatmap, and the next thing is that we also need to show it. Okay, and when it is run, you can see the out. You can see beautiful. This is our. Let me just zoom it out. You can see the graph clearly here. Okay, and you can see that here the state we have one is negative numbers, and it means that they are going in opposite direction. If it is happening in one city, then sure it's not happening in another city. You can understand it in that way. And you can see that we are getting lower values, so it means that the features are not that dependent on each other. So there is not that multicollinearity that we discussed previously. So you need to do it actually before the encoding. Okay, after that, but since I want to show to you how can you find it, then you can also do it this way. Okay, I hope you understand it and it is not that difficult.